Welcome, everybody. We're really excited to have Jeremiah and Nazar here today from Subspace Network, which is one of our portfolio companies in Stratos' Fund 1. And this is a fascinating project. It's basically a new layer 1 that separates storage and compute. It's also interoperable across a bunch of different chains. So we'll get into that. We'll talk about that. But first, just to start out, Jeremiah, I wanted to ask if you could just share a little bit about your background. And then Nazar, I'll ask you to do the same.
Sure. Thanks, Daniel. Thanks, guys, for having us on. Really excited to get to talk about Subspace. So I'm Jeremiah. I'm the co-founder and CEO at Subspace Labs. I have a pretty non-traditional background, but maybe that's typical in crypto these days. So I have 2 degrees in liberal arts, cultural geography. It's kind of like cultural anthropology. And then I was in the military for a while. And then I became like a self-taught developer and project manager at some different tech companies. And I think those 3 things come together actually really well in crypto because crypto is just as much about the culture and the community as it is about the technology. So it kind of really helps to understand both sides of the coin. You have to be self-taught in crypto because there's no place you can go to university and learn like how to do this stuff. You really have to be a self-taught kind of self-driven person. And in the military, they really taught us, like I was an officer, I was an infantry officer. So we did a lot of wargaming, a lot of what we call course of action analysis, where it's like, well, you do this, what does the enemy do? Like try to think 10 steps ahead. And it turns out that framework of thinking really helps when you're trying to do protocol design and security analysis. So all that sort of came together in a weird way to really set me up for what we're doing at Subspace.
Super interesting. What was your first exposure to crypto in general? And what was it that maybe pulled you in and made you excited or interested in the first place?
Yeah, I've been following crypto since the beginning, since like 2010, I think. Just in the news, I was never really technical enough to understand it. It was always, I really got the value prop of it. And I never was like risky enough to put my own money in it, or brave enough, I guess I would say, but I definitely followed it for a long time. And then it was in 2017, when I think my technical knowledge got to the point that I could really understand it. So during sort of the bull run around Ethereum and everything, it caught my attention again. And I read the Bitcoin white paper, reread it, and it actually made sense to me for the first time. I could actually understand, conceptualize how it worked. And then I was just fascinated and just kind of went down the rabbit hole, that everybody talks about, and have been doing that continuously for the last almost 5 years now.
I love your point around how important it is to be self-taught because there's no university, because I think that's incredibly true. That's also why it can feel really daunting and ambitious to try to learn this. Nazar, I'd love it if you could do the same thing. Just share a little bit about your background, and then we'll talk about the connection to crypto.
Of course. Thanks, guys, for having us. I'm Nazar. I'm co-founder and CTO at Subspace Labs. And I have a pretty extensive experience in open source development, especially. I was working on different projects over the years, especially in like distributed systems, overlay networking. This is something that fascinated me for a long time. I have a pretty technical background overall. I dropped out of university to found a hardware startup. After that, I was working with high-load systems in the live streaming company. So like the software development and building something new always excited me. And I was following crypto almost from the very beginning as well. I was farming since like 2013. It was very interesting to see what it is, how it can work, how you can use it, and was following all of these like waves, how the price was changing over time. And when we met with Jeremiah and we had this idea for Subspace, what it could become, that was really exciting things to work on, and I'm really happy to be here.
And how did the two of you meet and connect, and then decide that this was the problem to work on?
Yeah, it's a great question. So Nazar was maintaining an open source library on GitHub. If you're familiar with like BitTorrent, there's a way you can use it in the browser with a library called WebTorrent, and then there's a library even underneath that I was using for the first version of Subspace, which was like a browser-based overlay network, like a layer 2 kind of off-chain network. So the very first MVP, and it's very hard to work with networking in the browser. So Nazar was maintaining the library, I reached out to him on GitHub. We started having a conversation. We talked. It just kind of one thing led to another, and then within a few months we were working together. And that was over almost 4 years ago now.
Super interesting. Nazar, what was it like for you to get that message? And I don't know, any thoughts as you reflect back on that?
It was interesting. It was interesting because that was like a version of the library that was not designed for Node.js but for the browser, so people can use it in an environment where you don't need to install anything. And it was interesting that while the library was quite early, there was something who was already trying to build something useful for users with that library. So that got my attention for sure.
It's just cool to see someone using it to build something interesting.
and so this was in.
Go ahead.
Go ahead, Daniel.
No, I was just going to ask Jeremiah if you could tee up just the high level idea, because we're going to get into a lot of the rabbit holes here. But just before we go any further, I was curious because this is I think what you're building is both something that people can understand at a super high level, people that maybe have some familiarity with crypto, but there's also a lot of interesting stuff that you're doing technically. So I was curious if you could kind of share an overview for a normal person or someone who doesn't really know much about crypto of what you're building and why it's interesting. And then if you could share kind of an up-res technical version that gets a little bit into some of the interesting components.
Sure, yeah. So maybe it's a good place to start with kind of the problem that we're trying to solve, or what we see as kind of the fundamental challenge. So Nazar and I both come from a more traditional kind of Web 2 development background. We dabbled in Web 3 before, or whatever, distributed systems, whatever you want to call it. Decentralized applications. And one of the first things coming from traditional software engineering into this world that you realize pretty quickly is these systems just simply don't scale. They don't reach anything like the scale of traditional applications. It's really, even with a lot of the L2s and the more advanced L1s people are building today, like you look at it and it's like, well, you could run like one app on this blockchain internet scale, but you couldn't run like a whole suite of apps on these blockchains. So that was really one of the fundamental problems that really drove us from the beginning, is how do we get something that allows for people to build these apps at internet scale, how to use these applications, how do we support user adoption at internet scale. And that led us down our own sort of rabbit hole of like, well, maybe it's off-chain is the way to do it. Maybe we do it with an L2. And then, well, maybe there were some more exciting L1s we could build on, but then we were sort of maybe unhappy with the way this actually panned out. So then we started building our own L1. And it just kind of, we just kept peeling back the onion on what's really the problem here. And we got down to basically as low in the stack as you can go over a 2-year period, and a lot of R&D, which was funded by the National Science Foundation. Like we were lucky enough to get a grant from them. So yeah, so we really see it as we're trying to solve these fundamental, like systemic core problems in crypto around scalability, around energy efficiency. Obviously, blockchains waste a lot of electricity. This is a huge concern for a lot of people. We're seeing this as it's becoming more mainstream. There's concerns around centralization, like centralization is what we have. So if we build a centralized blockchain, it's kind of like, what's the point? There's concerns around incentive compatibility. There's all these sort of fundamental problems, and ultimately what we're trying to do is really just solve all these problems so that we can make blockchains, we can allow blockchains to serve as the backend infrastructure for user-centric apps where people can own and control their data, where people can sort of have self-sovereignty on the web, on the internet. Bitcoin kind of showed how you could do this with money at a very limited scale, and we would really want to see this kind of as much as it can play out.
And I could pause there, Rennick. Yeah, feel free to jump in.
Yeah, so my question is, so you're talking about a lot of issues that blockchains have today, or that are obvious to everyone in the space today, right? Like Ethereum gas fees are so high, there's so much congestion. This is the result of a number of years of, compounding in terms of more people getting interested in the space, more developers entering it, more venture money flowing into the space, and really it flourishing. But in order to get to where you are today, and all the years that it took you of research and building to get here, you had to foresee the scenario that we're in today 4 years ago, right? So what was it that really made you say, okay, this stuff isn't going to scale and we need to build something different? And what was that moment that made you decide this was one of the issues that you needed to, or the issue that you wanted to tackle?
Yeah, that's a great question. I was trying to build an application on Ethereum. I'd written a smart contract, and I was using IPFS for storage. I'd been working on this traditional Web 2 app, and I was trying to figure out how I could port it to Web 3. And at that point, the slogan was like, IPFS is your Amazon S3, Ethereum smart contracts are your EC2, and there was this other project called IPDB interplanetary database, which was supposed to be like your MySQL or your Firebase. And I was trying to build an app with these three things, and it was just really clear that it just like right off the bat, like it just wouldn't scale. Like, you know, if I had maybe 1,000 users, it would break the blockchain, which CryptoKitties did about that time. And so, yeah, I just saw that and so, well, there's obviously a lot of appeal for this technology. I mean, it would be great if this would work. It's just a question of like, can it work at scale? And if it did, that would be a huge opportunity for the world, really, for everybody to build these apps, for developers and for people to use them. It seemed like kind of the way what we want to move towards. So just that was kind of the problem that I set on to solve at that point.
And so then, you know, obviously the design that Subspace is based on is in a lot of ways very novel, but in some ways the rest of the ecosystem has sort of started to move in this direction. You know, you guys are really far ahead, but what does that feel like when, you know, you foresaw this, you started developing this architecture, it seems now that this is certainly the way to go based on what everyone else is doing. What does that feel like?
I think a lot of people maybe foresaw it in the past that there was going to be scalability challenges. And there were a lot of, even at that time, there were a lot of, you know, like Lightning Network was the big thing everybody was excited about back then, or Plasma on Ethereum. And I just remember like trying to learn them and not really being able to understand them or reason about them like the way that I could about Bitcoin, and just kind of had a gut feeling that they just weren't going to work. And they've all kind of like failed, honestly, in my opinion. Because of complexity or because they make all these trade-offs. And so I think a lot of people have been working on these things for a while. And there's definitely some other great ideas. Like we don't claim, you know, to have the, monopoly on good ideas. And a lot of our ideas really come from other projects. We've tried to incorporate the best ideas from other projects. We study other projects very, very heavily. But I think we're just kind of obsessed with like not making compromises at the end of the day. And a lot of people are willing to make compromises and trade-offs and sacrifices. And we just really want this to be like a very, I don't want to say perfect, but like the best possible system given, you know, fundamental computer science constraints.
I think that's fascinating. I'd be curious, you know, you talked a little bit there about just the other approaches that other chains, and these could be layer ones, layer twos, are using to try to solve some of these problems. And it seems to me that there's some sort of underlying philosophy that you guys are working with in terms of why you feel so passionately that you should make those trade-offs. Because I think one of the interesting things in crypto, you know, when I talk with other people about, I don't know, get people's insights on Ethereum's work around scaling, is you have people that think it's workable and you have people that are like, absolutely not. It's absolutely never going to work. So I'd be curious just for your take on what is that philosophy, and I guess what is that like axe to grind with the trade-offs or the other approaches that some other projects are using?
Sure. Yeah. I think so. There's this obviously this blockchain trilemma that Vitalik has talked about quite a bit. I think it's often taken at face value, maybe inadvertently on Vitalik's part, but a lot of people assume that it's kind of like a law of blockchain, that like you have to pick two, you can't have all three. And it goes back to this like cap theorem, you know, in computer science, which people often take as a law that you can only pick two, but it's really just kind of a mental model for how to think about things. There's not like an impossibility theorem. And we just never really accepted that, I guess. And other people were looking for maybe, I don't want to say shortcuts, but maybe the low-hanging fruit and like what's practical today, like what's achievable today, what's achievable in the next 6 to 12 months. And we've been more thinking like, well, what's fundamentally, like, is there a fundamental reason why this can't work? If there's not a fundamental reason, then let's keep moving in this direction until we can figure out how to make it work. And let's like read really widely and like get other smart people involved in the conversation and see what they're doing.
Yeah, so it's a very
different
approach.
Can you define what that trilemma is?
Sure. Yeah, absolutely. So the blockchain trilemma, it's a blog post Vitalik wrote back in 2017, I think, where he talks about blockchains that have three properties, or can have three properties. One is security. So this is the honest majority assumption, like half the miners have to be honest for the protocol to work, and so that's a secure blockchain. The other property is decentralization, so that there's not a single server, there's lots of nodes, like 10,000, 100,000 nodes at one point in Bitcoin, or miners. And then the third one is scalability. which everybody wants, right? And he says you can only really have 2 out of the 3, or there's like a triangle, and you have to. It's like a design trade-off space that you have. So you can get maybe scalability and security, like maybe Tron as an example of that, but you lose centralization, or like Solana, maybe you lose decentralization, so you have to give up centralization to that. Whereas most blockchains like Bitcoin and Ethereum, they sacrifice scalability, but they get decentralization and security. And the traditional cloud would be scalability and security, perhaps. Well, I guess that's Solana. But so that's the idea. And when somebody says, well, you can get all 3, most people just say, well, that's impossible. That if that could have been done, it would have been done, or like Vitalik would have figured it out, or somebody at Ethereum would have figured it out by now.
And so if you want to take a stab at just in simple strokes, how Subspace is able to do that.
Yeah. So there's really 2 parts to our approach, and this blockchain trilemma even is an oversimplification of the problem. There's like many facets. Like when you say scalability, what do you mean? There's different dimensions of scalability, like horizontal scaling, vertical scaling. There's different dimensions of decentralization as well. Like how powerful does a node have to be? How many nodes do you have on the network? Are there upfront costs to running a node? So there's a lot to this. So I'm having to simplify things a little bit here. But basically, there's 2 ideas. 2 problems. So one is this problem of how do we scale without sacrificing security or decentralization. The other is how do we solve this other problem of blockchain bloat, which is a byproduct of scalability, which leads to more centralization. And so these 2 problems we actually kind of dealt with independently. So the first problem of blockchain bloat is actually what our consensus protocol solves, this proof of archival storage. The second problem of how do you scale while maintaining security and maintaining decentralization, at least in terms of the hardware you need to run a node, that's actually a problem that was solved by some other researchers that we're working with at Stanford, David Say and his group. And they designed a series of protocols that kind of get at different aspects of this. Luckily enough, they designed their protocol to be kind of abstract or generic over any Nakamoto consensus protocol, any longest chain Nakamoto consensus protocol. So that could be proof of work, proof of stake, proof of storage. And we designed a Nakamoto consensus longest chain protocol that just happened to use proof of storage. So you can kind of put them together. And it turned out that when we put them together, we got unexpected side effects, really nice side effects that didn't exist in either of them independently. But when you put them together, you get like a whole new scaling paradigm.
And so just to paraphrase that, you've got the bloat problem, which is you basically have to store all the state. And the state is, thinking about holding all the data that defines what's going on the ledger. You're taking all of that accumulates over time. And so what that does is it slows down most blockchains, or it increases the amount of data that needs to be held. Whereas with Subspace, the proof of archival storage is holding that data and creating an incentive system for people to provide storage to offload that to. And then the second piece is the actual execution component, or the compute layer that takes whatever transactions or smart contracts are being committed to that chain and helps execute them at a level that is a speed and throughput that is very high without actually needing very specialized technology.
Yeah, I'd say that's pretty fair.
Nazar, anything to add to that? We've kind of covered a lot of ground really quickly, but anything to add? And I want to come back around to the number of groups that you guys work with and talk a little bit about the National Science Foundation grant that you had, because I think that's something that's really interesting and unique about this project. But Nazar, any thoughts to add on to that?
Yeah, I think it's also important to note that there are actually 2 parts that regular full node has to store on the network. The first part is the state, like the state of the smart contract. This is just accumulation of all of the transactions that happened on the network since the beginning, since Genesis. And that can be big, but it's usually not that big comparing to the other part, which is just the history, right? When you join the network, you want to make sure you are on the longest chain. And for that, for the maximum security, you need to download the whole history from start to finish. And if that history is very big, then on the network, there will be very few nodes that actually are able to store it. Let's say if it's like 4 terabytes, then how many regular laptops have 4 terabytes of free space to spare for this purpose? And it's really important to keep decentralization of that part such that network is recoverable and secure, such that everyone who wants to join the network later can actually do that. And the big part of the protocol is to shard this like to slice this state and make sure that every single node stores only a small slice of it. But in total, the whole system can recover the state from those small pieces with very high probability.
Super interesting. Jeremiah, would you mind talking a little bit about, you're the first project that I'm aware of that has been working off of a National Science Foundation grant. So I think that's really interesting. How did you guys get that? And I guess what did that enable or unlock, and what did that fund?
Yeah, I haven't seen that many either, to be honest, or at least L1s. There've been some DApps that have gotten NSF funding, and they tend to be more like enterprise or government focused. So I had a friend at another startup who got one of these grants, and he just suggested we apply based on what we were doing. He said they would find what you're doing interesting, and they actually just started a blockchain track, or they call it DLT, or I don't know what they call it now, distributed ledger technology. That was the government sort of buzzword back then. But we applied, and we really kind of pitched it like it is really as sort of a social good that we're building, like a public good for like just creating sort of a new model for the internet or for the web for application developers to build these apps, these DApps or smart contracts where the user has sovereignty over their data. And they really liked it, and they gave us the funding, and we made it clear that we were trying to solve some really, really hard problems. And the two criteria they look for are basically, is it very, very likely that you will fail because you're trying to solve such a hard problem? And if you solve the problem, it will have like a huge impact. And so they were like, yep, you qualify for both. We'll give you the funding. We had not raised much funding at that point. We were still in this sort of like venture valley of death and, like bootstrapping. And so that gave us like a year and a half of like solid runway and breathing room. And it wasn't like, you see so many projects in the space where it's just like, get something out the door as quickly as possible, do an ICO, there's a lot of like speculation around these things. And we just stepped back and said, no, we're actually going to stop and like really evaluate, the market. We did like a whole bunch of it wasn't just research. There was like a whole bunch of customer interviews, like marketing experiments we were doing, like alongside this at the same time, trying to even validate that like the thing that we were building, people actually wanted it, that it actually mattered. We just had this nice like 18-month period where we could just really step back and take the time to try to dig deep into these problems.
Yeah, it's fascinating. Just one follow-up question on that. I mean, so obviously, I love that model in that it has to be a very hard problem that you're likely to fail at. But if you are successful at it, it unlocks some sort of massive impact. On that note, when did you guys cross that chasm of it being too difficult to solve to being solved? And are you there now? Is that sometime in the future? Give us a sense for where you're at in terms of kind of that milestone.
Yeah, I think we definitely with about maybe month 12 of the research, we had really figured out the consensus protocol, the proof of archival storage, and we'd identified the major security issues, and we'd figured out the resolutions to them. So by that point, we had like the basis of our protocol, the basis of everything else worked out. There was still more stuff we did around the execution, which came later. We wrote a white paper about 6 months after the grant term ended, which kind of explained how the decoupled execution works, which is a big part of our protocol. And then luckily about the end of that time frame, I was able to get really well connected with some of the researchers at Stanford and really get tied into what they were doing and follow that line of work. And that sort of solved the second problem of like, okay, you have this like nice base layer, but like, how do you scale it? Like you have this like energy efficient, like open, permissionless, like fair Nakamoto consensus algorithm. But then how do you build a scalable blockchain off of that? And it turns out that when you build a scalable blockchain, like you get this bloat problem, which Nazar talked about. And that was something which they figured out, like, okay, we can generate a terabyte of data a second, right? We can generate like 1 million transactions a second, but like, who's going to store that terabyte of data? And our protocol just happened to be really great at like distributed incentivized storage of that terabyte of data that's generated per second.
Mm-hmm. Rennick, I was curious if you could jump in and share a little bit about, so at Stratos, one of the things that we're focusing on is infrastructure, which is by its very nature these like very hard to solve problems, which is also very unique in that it doesn't seem that that's where the majority of kind of venture dollars are going. What was it that was interesting about this project, and can you just talk a little bit about the investing in infrastructure thesis?
Yeah. So, and I want to go off of what you just said, Jeremiah, and what Nazar said earlier. So, because I think all these things feed into it, but I think just generally speaking, as we think about infrastructure, it's okay. We understand at this point, or at least the people in this industry, I think, understand the value of distributed ledgers or decentralized networks, and what Web3 broadly can mean for people, and how it can really be in some ways sort of the antidote to like the issues with big tech and FANG today. But if you think about where Ethereum is right now, the gas fees for using Ethereum are so high that it's like only the top 1% of the crypto population can afford to actually interact with it. And so just scaling is known to be this major issue. And there's a lot of different ways to go about solving scale, which is another way of just saying it costs too much to commit transactions to the chain. If we want this technology to become something that really can change the world for the better and impact, especially people who are, excluded from the traditional financial system or the Western financial system, and want to be able to transact. If you're paying $100 in fees for a $2 money transfer, it's never going to work, right? I mean, and if you think about what the average transaction like on the Visa network is in terms of value, it's lower than that. So your fees are going to be more than the transaction's never going to get to where this can go. And so, we're very focused on, okay, how do you solve the scaling problem? And there's a lot of different ways that you can solve it. When we first talked to Jeremiah and learned about Subspace, we didn't necessarily expect them to be solving it so directly, because all the other solutions in the market so far are kind of like compromised in one way or another, or they're, for example, if you look at the way that you have to design things in Ethereum for them to scale, you end up just having to kind of reduce the functionality of the application in ways that you would prefer not to if gas fees were extremely low. And so when we saw Subspace and we saw that it was solving the bloat problem, well, that in and of itself is a really interesting infrastructure problem to be solved. And so there's a couple of other projects like Filecoin and Arweave that are pretty well known, that are various forms of storage on chain. Well, we looked at Subspace, we said, okay, well, Subspace does that, but then it also has this computation layer on top of it that also is extremely performant. And then kind of saying, okay, well, what does that mean in terms of our overall thesis? And if this is possible, does that change how we think about infrastructure in the entire ecosystem? Because now you can couple these things, and where does that go? And so I think where we think about it going today is we see so many different blockchains that in essence are becoming their own ecosystems. And then there are bridges between the chains that help them send value between each other, but they have a really hard time talking to one another. And one of the things that we always kind of have said in our investment committee meetings is, well, if you can invest in the thing that enables all these chains to work together, that's an amazing position to be in, because I don't think we're going back to a world where there's just Ethereum. There's going to be many chains. But in order for this to really scale, where an application developer can just write something and it can function across all the chains, that's eventually where we're going to go. I think inevitably we'll get there. The question is how, right? Today, it's not obvious exactly how you get there, but one of the first steps of that is allowing all these chains to interact. And so if you said, well, Subspace has a couple of unique components to it. One is that it has the ability to store all this state and history because of the incentivized storage, and we should talk about that in a second. And it has a compute layer on top of that. What you can end up doing is being the one source of truth for people who want to operate on multiple blockchains in parallel. And so in that way, it kind of becomes that multi-chain enabler that we've been looking for. It's just doing it in a way that was completely different than what we were expecting to see. But now that it's in front of us, and we got to know the project and obviously co-led the seed round, it's something that we think we're super excited to see where it goes, and think that it can be like a major enabler of all the next wave of development that we think is going to happen.
Anything to add on to that, Jeremiah? Any thoughts?
Yeah, bridging is definitely a big component of what we're doing. And it's funny because we get this archival storage like somebody like Arweave does, or we get this like decentralized storage like Filecoin. You can somewhat compare it to that, but we don't really do that by design. We just do that. It's like a side effect of our protocol. It's a side effect of our scalability that we get this. Right. And the scalability allows us to create bridges in ways that most people can't, where we can just literally just ingest all the data, like just literally archive the entire chain. We're doing this for Polkadot and Kusama right now in our test net. And that makes the bridging problem so much easier, because now you just need to validate the data as you're bringing it in. You just need to validate the block headers. And now you've got, as Rennick said, you've got a single source of truth for all the data. You got a single source of truth for all the history. You want to create a cross-chain credit score identity aggregator. There you go. Here's all the data. You've got a compute layer. You can run smart contracts over that. So it's almost like, in a way, it's a little bit like big data on a blockchain, but it's public. It's open. Anybody can get to it, right? It's not like siloed with some tech company having access to the data. And that's one of the interesting things, one of the interesting side effects about Subspace. But we are really focused on bridging, archiving, and connecting all the chains. And eventually, we'd really like to connect them all. We'd like to have them all committed to Subspace. We're cross-committing Subspace to other chains, and we get this interesting sort of like entangled state, or like web of interconnected blockchains, where really you can't attack one blockchain without attacking them all. So we really feel like in addition to just being a scalable blockchain on our own, we can kind of help bring the whole industry forward by making like everybody more decentralized, everybody more secure, and potentially more scalable too, if you're going to offload storage or compute from one chain to another.
It's fascinating. Nazar, I'm curious, the interoperability problem seems really fascinating. I don't know it with enough technical nuance to know kind of where to dive in. So I guess just the simple question over to you that I would ask you is, can you just share some of your thoughts around like how hard a challenge was it to tackle interoperability? And I don't know, any thoughts on your implementation today and where you think that goes?
Yeah, I think the size of the data is a big problem. If you want to verify something, you need to ingest some data. And a lot of solutions, they focus primarily on how to reduce that amount of data. And often they have to make certain assumptions about the security guarantees that they can achieve. If you want to pull the full header of a particular chain onto Ethereum, that costs you quite a lot of gas, right? And that means that you will try to avoid that, and you'll probably verify only the portion of the data, or you will reduce your requirements somehow, and that makes the bridging more difficult. If you have this ability to ingest massive amounts of data for low cost and make sure that it will be persistent forever, basically, and you can verify the data, then suddenly these problems kind of go away. So it's like really interesting to see that other protocols, they try to minimize the amount of data, and they basically say, why would you want to store this all on chain? And for us, it's just like, you want to store something, put it in transaction. It's just that simple.
So how do you create the incentives for users to provide storage that the network can use?
Yeah, this is the foundation of our protocol consensus. Basically, the idea is the following. Instead of burning electricity, where it's just a lot of energy wasted on Bitcoin to achieve consensus, proof of work, or proof of stake, where the concern many people have is that rich people get even richer, and it's a high barrier to entry. It's basically like permission system. We are saying that there is this useful service of storing the history of the blockchain, right? What if you make people earn the chance to generate a block based on how much of that history they actually store. So you basically slice the history of the whole blockchain into small parts. We encode it in a special way and let farmers store that data. And proportional to how big is the slice of the history that they can store, it is basically proportional to the probability of winning the block reward. So this way, we are not having like a separate function that is orthogonal to the blockchain itself. We are providing objectively useful service to store data, and that happens to be the consensus mechanism. So blockchain basically supports itself, and we no longer have this problem of blockchain bloat. Is basically an asset. The more storage we have, the higher is the replication factor. The more reliable storage is, the cheaper it gets to add new data to the history.
Yeah, and so if you roll that forward a little bit and assume a state of the world where a lot of people are providing storage to Subspace because the incentives to provide that storage are quite high, what does that mean for Subspace? That you can envision a state where there is a huge amount of storage available to Subspace because of that incentive system, right?
Yeah, I mean, or go ahead, Nazar.
Yeah, so that is an interesting mechanism that is actually built into the protocol, right? Just like in Bitcoin, where you have the solution to the challenge, the proof of work, you can approximate how big the hash power in total on the network is, right? Just from that solution. We have something very similar, which is a solution range, like how close is your solution to the target, that can allow us to approximate the amount of space pledged to the network. So basically, we know how big is the farmer network, and obviously we know the size of the blockchain itself because that's our history. We track that on chain, so we can know what is the number of times that blockchain is replicated in the network, how much redundancy we have. On the other hand, we obviously know the coin supply on chain, and we can basically derive a parameter that is cost of 1 byte of data. How much it would cost if all of the excess storage, like all of the excess replication that is present on the network, how much it would cost to cover that with the whole coin supply, right? And it actually only depends on the real world cost of storage. It doesn't depend on the price of the coin, because as the coin gets more expensive, more farmers will join the network. There will be more slack capacity. The price in coin will go down. So we basically have this interesting mechanism of automated market maker. When the bigger network gets, the cheaper it gets, more users we get, and then more farmers join. So it's like it is self-sustainable, like this cycle that feeds itself and just keeps growing.
Yeah, and one thing to note about that is the storage is generalizable. It's not just necessarily transaction data, but it can be. It's any application that is written to the blockchain that wants to store data of some kind can be part of the Subspace network data, right? So it could be as broad as, you know, Amazon one day in that sense. AWS.
Yeah, you're absolutely right. It's just basic object storage. So it's just a key value store at the end of the day. And we just happen to be putting, right now, most of the data we're putting in is transactions and blocks from other blockchains. We're starting to put NFTs in there too. But really any data you can imagine, you can put in there. It's very abstract.
Yeah, and I think the mechanism for driving down the cost of storage is really critical here, because right now, like so much wealth has been created in the blockchain space that people are willing to pay more for storage on other chains just because it's decentralized. But that's not going to be the thing that really matters long term. Like that's not what's really going to scale, in my view. What really matters is being able to say, this is the same cost as what AWS would be or Azure or some other option. But it's also decentralized and much more secure. And so I think, you know, the way that you guys have gone about thinking about the incentives here is really critical for helping us get there.
Yeah, an important difference is actually that the storage is not just like temporary, it's there forever. It's a slightly different programming model, like use cases that you can use it for. And it also means that we are not necessarily conflicting with other storage protocols. Like there are protocols that are providing temporary storage. So you wouldn't want to put your NFT in the temporary storage because it will be gone in a year once you stop paying. So this is something that you would really, really want to put somewhere where it's safe. And there are some other things that are not that important that you can store for a little while somewhere else.
Jeremiah, I was curious to ask a question to kind of move on to a really different part of what you're building. I'd be curious to talk a little bit about the developer experience of building using Subspace, especially as you shared at the beginning this kind of experience you had early on of having to use IFPS and this other interplanetary database and kind of all of these things, and it starts to feel like it sounds very duct taped together, which obviously doesn't sound like a great experience at the end of the day. What is it like to work in and build on Subspace, and how is that? I guess how different or kind of revolutionary is that, just as a basic developer experience?
Sure, that's a great question. So a lot of the earlier questions around the protocol, the research and development on the back end, that we're pretty far along on that. But the question you just asked, this is something we're still pretty early on, to be honest. We do have a library called Subspace.js, which we started testing about a month or two ago, and we actually used it in an NFT hackathon we were at last weekend. And Subspace.js is the developer tooling that exists today. Which is a wrapper around Polkadot.js that incorporates some of our unique, basically write data, or we call it a put call, and read data, or a get call, which is talking directly to the Subspace network, basically directly to our test network. That's what it is today. This is like the plumbing, so to speak, of our protocol. We don't have any compute plumbing yet, but we're going to have it soon. This is something we've been working quite a bit on recently. Mm-hmm. And what we're trying to do right now is get this plumbing done. The plumbing is really the blockchain APIs itself, but we don't expect most developers to use the plumbing. We expect them to use some Porcelain, which we're also working on building. And this is something which we've also been focusing pretty heavily on lately, is the design of this. And we have some ideas right now around a product suite which we're planning to launch called Subspace Meta Services. One of these is something called Meta Vault, which is an NFT storage service. It kind of looks like something like the console looks like something like traditional kind of Web 2 storage interface or developer console interface. But it's a DApp, basically. It's all hosted and run on chain, and you're authenticating using your wallet. And we're just trying to make it as simple as possible. This has been a big goal of ours from day one, is really as simple as possible for developers, especially like front-end developers, full-stack developers, not necessarily protocol engineers or smart contract developers, to build on our protocol. Yeah, so that's kind of where it's at. It's still very early though.
I love the terminology of plumbing versus porcelain. I haven't heard that, but I think for anyone that's built things, it makes a lot of sense. So just to kind of take that question and raise it up, a little bit higher level. So you clearly, you guys have now spent a number of years working on the hard technical challenge, working on then the APIs. And so it sounds like where you're at now is basically working on the problem of how you wrap those APIs in something that's really usable and potentially a suite of different services. Can you give us a sense of, is that the next year? How long does it take for you guys to go from where you are now to kind of launching that? And what does that look like? I know you guys have a testnet today. You're maybe participating in some hackathons. How do you go about getting more exposure to more developers and kind of validating that and continuing to build it?
Yeah, we're still pretty early there. We're on the second iteration of our testnet. You can actually you can use Subspace.js and put data on our testnet. It's also free. You don't have to pay a cost of storage right now. We are probably soon. We're working on releasing this NFT storage interface. I don't want to give an exact date, but it's going to be soon. By the time we launch our network, which is going to be towards the end of this year, is the target right now. We're definitely planning to support basic storage and compute, smart contracts, and also we're going to have probably NFT storage, the ability to swap NFTs or to trade NFTs, and bridging. That's almost like a more plumbing thing. Like, I guess you could say like cross-chain swaps is really what it looks like to the developer. But these are some of the things that we're focused on immediately.
Yeah, super interesting. And when, like, so you guys launch at the end of this year, how long will you guys have worked on the project to take it from this initial conception, trying to really understand what problem you're solving, all the way through getting the protocol live? And just for a bit of color, I mean, the part of the reason I'm asking this is I feel like there's not enough discussion of here's how we approach this and kind of sharing that openly with other developers. So it's more, it's less about, kind of giving dates. And I think more if you can just share what goes through your mind as you think about that. That process, that journey.
Yeah, it's been a multi-year process. I mean, like, we're big fans of Polkadot, and it took 5 years after the white paper came out before they actually launched pair chains on Polkadot. So that just gives you an idea of the timescales it takes to do this stuff. So we started March 2018 working on this, and it was probably about March. It took about 3 years for us to really figure out the hard technical problems. So March of last year, to really get to the point where we're ready to go out and really confidently raise money and say, let's go out and build this thing. And now we're at the point where we're scaling that up quite a bit. So yeah, I'd say 4 to 5 years is really the time frame it takes if you want to really build a true L1 or a new blockchain network that's meaningful, and get it deployed.
And do that not around compromises, but around basically not flinching on anything, trying to solve ambitious problems. Rennick, I have a couple of... Go ahead.
Yeah, I was just going to say, like, even Near, which started around the same time we did, I mean, they're just now launching sharding. I mean, they've had a live network for a while, but they're just now getting to the point that they're having like sharding on their network and doing something that's really, new and unique. So it takes quite a while.
Yeah. Rennick, any closing questions from you? I have a couple I'll ask, but I'll let you go first.
I guess from now until launch, or I suppose after launch, what are the things that you guys are most excited about or looking forward to as being kind of like watershed moments for the project?
So one big one, which is actually coming up soon, is going to be the launch of an incentivized testnet. Incentivized farmer testnet. Another big one is going to be the ability to deploy smart contracts on Subspace, so that not only could you like store your NFT data on Subspace, you could mint your NFT, you could swap your NFT on Subspace. Another big one is going to be the ability to do a cross-chain transaction on Subspace with Ethereum and with Polkadot and Kusama. These are all things which we're planning to support before mainnet launch. And then, of course, mainnet launch, we're going to be doing a community sale around our mainnet launch, and the launch itself, we think are going to be pretty big.
Yeah, it's exciting. I mean, those are all the major stepping stones from now until launch. The incentivized testnet, the smart contract compatibility, bridging between the two kind of best known, or at least Ethereum. Polkadot's one of the big follow on, new generation chains. But yeah, that I'd be excited about that too. We are excited about that.
One question I want to ask both of you guys, and we always ask this question, is, so we talked about that you've been on this multi-year journey. You guys still have the rest of this year, obviously, to kind of continue a lot of execution work to get to this mainnet launch. What, as you reflect back, what has been, one of the highlights, and I think it would be great if you could talk about, just what it's like to kind of persist through. And I don't know, maybe this was the first year of the project, maybe it was more the second year once you got out of solving and thinking about the hard technical problems and starting to implement it. But talk a little bit about some of the highs and some of the lows you guys have experienced and what you've learned from that over the last couple of years. Maybe you could start, Jeremiah. Go to you, Nazar.
Yeah, there's so many. I mean, well, you've got the highs and lows of the market, of course, in the background. And yes. I remember like so many teams that I was talking to, friends that I had that were in this in 2017, 2018, they've all moved on to other industries. They were like, oh, you're crazy. You should get a job, like go get a real job. blockchain's going to die. Like how many times people have said like this industry is going to die. So there's definitely been some around that. There's definitely been times where, you know, when you try to solve really hard problems that sometimes you feel like you just can't solve it. Like maybe this is unsolvable. And you get to the point where you're ready to give up, but then you just like take some time off, get a fresh perspective, or go talk to somebody else and get their perspective and find out actually maybe there's a way to solve this problem. So there's been a lot of that. And then it's just a lot, and Nazar can really speak to this. I mean, it's one thing to have the idea, even to have the protocol defined in the specification. It's another thing to actually write all the code. It's like so insanely hard to really write these protocols, and then to get them to be secure, like the implementation to actually be secure, and like the benchmarking, like the scale of it, like does it actually scale like the way you think it will? Like there's all these like hidden gotchas. And so, yeah, and so it's just, you really have to have a lot of endurance to make it through this.
Nazar, be curious for you to add on to that, kind of share your perspective.
Yeah, it's really like a alternate like current where you think you know it and you're like almost there, but there is some problem that you gotta solve, and then you're like down again. And I think the last year was the most exciting in a sense that we finally had more of these like aha moments where we finally solved this like part of the puzzle, and we can finally move on to the other one. And as we get closer to the mainnet launch, more and more things get like super clear, and we can finally just like build it, having like a very solid plan. In the previous years, a lot of time we had this like idealistic view, like this is what we want to achieve. We don't want to make these compromises. We don't think they are the fundamental limits of the like hardware and computer science. But no one really did it the way we wanted. So it was still like, for the most part, an open question whether it can be done. And that's why we had the grant from National Science Foundation. But today, I think we have way more confidence that this is something that we are going to launch.
It's exciting. Last closing question for both of you guys would be just a piece of advice that you would pass on, you know, either to yourselves, if you go back in time and maybe whisper something into your ears when you were starting this project, or just to other teams that are 3 or 4 years in to solving a really ambitious, really difficult challenge. Any advice that you would share?
Yeah,
it could be anything.
We hire a lot of, I mean, we try to find really good protocol engineers, really bright people in the space. And I think when I started down this path of like, let's design a better blockchain, it was like, let's throw out everything that there was before and start over with a blank page. And there's really quite a bit of brilliance in Bitcoin, in Ethereum, in all these other, you know, competing third generation L1s. And really, it's worth taking the time to really look at what everybody else is doing in the industry and try to and pull out the right elements of that.
It's well said, especially when you're trying to build something new, but you don't want to throw out all the great stuff that already exists.
Yeah, a lot of what we are doing at Subspace is like a combination of other different brilliant ideas from other people. There is something that we brought to the table, but a lot of those ideas were already out there, and often just not implemented by anyone yet. And there are many teams that are working on those things in different combinations, let's say. So there is still a lot of things to be implemented that scientists already kind of figured out. They're just waiting for builders to go build it.
Well,
that means you're on the edge, you know, the edge of practice and theory and science. So that's pretty exciting to know that, you know, you guys are right there.
We appreciate the time. Would you, Jeremiah, just share quickly how people can follow the project? You know, the website. I imagine there's a Discord community or some sort of social community people can join. Where can people go to learn more and to kind of participate?
Yeah, thanks for the plug. That's a great question. So subspace.network is our website. Up at the top right, there's a Discord link. A lot of our communities in Discord. There's also a Telegram link. We have a really active Telegram. Follow us on Twitter. Network Subspace is our Twitter handle. And follow the Medium. And GitHub, of course, if you're an engineer, go to our GitHub. Everything is open source. Everything is out there. Yeah, those would be some good places, and apply if you guys are interested. If you're smart and you're hardworking and you're in the business or the engineering side, doesn't matter, and you want to work on a really impactful project, please apply. We're hiring.
Really well said. We really appreciate the time, Jeremiah, Nazar. Thank you so much for joining us.
Thanks, guys.
Yeah, likewise. Thanks for having us. We really appreciate all the questions and having the chance to talk.
Yeah, thank
It's
you.
fascinating.
We'll talk to you soon. All right. See ya.
Bye,
Bye, guys.